Okay, Year 12, Lesson 3 for transformations. This lesson is on reflection. So this is what we've done so far. We have reviewed how to graph functions. Then we looked at vertical and horizontal translations, and then vertical and horizontal dilations. A particular type of dilation is reflection. We can reflect a graph over one or both of the axes. But this is what we say. We say the graph is reflected in the x-axis or in the y-axis. And here's an example of a graph being reflected in the x-axis. You see when k becomes negative, it flips over the x-axis. So let's have a look at what happens to the equation of the function if we want to reflect in the x-axis. All we do is stick a negative in front of the f of x. And can you see how this is a type of vertical dilation? It's a vertical dilation of -1. Here's an example. If we have y equals e to the x, the reflection of that in the x-axis will be y is equal to negative e to the x. If we want to reflect in the y-axis, we stick the negative in with the x. Can you see that this is a type of horizontal dilation? It's a horizontal dilation of -1. Here's our example. How do we reflect y equals e to the x in the y-axis? It's e to the negative x. Okay, let's look at a couple of examples. For the function f of x is equal to x multiplied by x minus 2 in brackets, draw negative f of x. Okay, so this is a reflection in the x-axis. We're just going to flip that graph upside down, and it's going to look like this. So that's the answer to A. Now let's find f of negative x. So this is a reflection in the y-axis. So it will come across like this. So this is B. And then finally C, we want negative f of negative x. So we want two reflections. So we can just reflect either A or B in the other axis. I'll do B. So I'm just going to turn it upside down, and it's going to look like that. And example 2. Point A, which has coordinates 4, -5, lies on the curve y equals f of x. What happens to point A if the curve is dilated vertically by a factor of -2? So remember, vertically is going to affect the y coordinate. And this y coordinate is going to get twice as big, and it's going to be negated. So it'll actually become positive. So point A is going to become 4, 10. Make sure that makes sense to you. How about horizontally by a factor of -2? So horizontally affects the x-coordinate. The x-coordinate is going to get twice as big, and it's going to be negated. It's going to become -8. But the -5 doesn't change. Now let's write the functions for those transformations. So for A, this was vertically by a factor of -2. What are we going to do to this? Can you see it's going to become y is equal to -2 times f of x. And B, horizontally by a factor of -2, this is going to go in with the x, but the 2 is going to become a half. So it's going to be y is equal to f of -1/2 of x. And example 3. Recall that horizontal transformations can affect domain and vertical transformations can affect range. What is the new domain and range if y equals the absolute value of x minus 1 is reflected in the x-axis? So we're going to start with what does this look like and what is its domain and range? Now it's an absolute value graph and it has horizontal transformation in it. Can you see that? It's been shifted over to x is equal to 1. So what's its domain and range? Let's write it up the top. The domain is all real x, so from -infinity to +infinity. And what's the range? Everything from 0, including 0, up to infinity. All right, so when we reflect in the x-axis, we're flipping it over, aren't we? So our domain hasn't changed. It's still -infinity to +infinity. But the range has. It's everything from -infinity up to and including 0. Now what happens if we reflect in the y-axis? We're taking it over the y-axis. Domain doesn't change. And neither does the range, does it? It's still going to be 0 up to infinity. Okay, that's it for this lesson. It was short and sweet, but I want you to really focus on those 3 types of transformations before we get to our next lesson, which is where we're going to combine them all.